All right, welcome. We are still looking at section 3.2, and we're going to look at common misinterpretations of confidence intervals. So misinterpretation 1, a 95% confidence interval contains 95% of the data in the population. No, that's not true. That 95% comes from 95% of the samples will contain the true population parameter. All right, misinterpretation number 2. I'm 95% sure that the mean of a sample will fall within a 95% confidence interval for the mean. That's also not true. We know that we're 95% sure that the mean of the population will fall within a 95% confidence interval, not the sample. If you have a sample, the sample absolutely will fall in the confidence interval because it's the exact middle of the confidence interval. Misinterpretation number 3, the probability that the population parameter is in this particular 95% confidence interval is 95.95. And that is not true. Again, we're not looking at the probability of any one specific interval. That 95% pertains to the total number of confidence intervals that come from different samples. So I'd suggest read over these again. My suggestion on these is you to write these down and try to explain in your own words why these are not correct interpretations of the confidence intervals. It's a very kind of subtle part of this course, understanding the background of these confidence intervals. All right, just kind of as a graphic, just to visualize what we're doing, we've got a population that we want to know something about, some proportion or average, something like that. So then we take a sample. And ideally, that sample is going to compute a statistic. From one sample becomes a statistic, but what about this ME, this margin of error? From that, we would, in theory, need to do many samples. So each of these samples will calculate a statistic for each sample. And that'll give us a sampling distribution you see down here. And from this sampling distribution, we can compute a standard error. Standard error is the standard deviation of a sampling distribution. And from that standard error, we can compute a margin of error. The 95% confidence interval, the margin of error is approximately 2 times the standard error computed. And then from that, we get the margin of error. So keep in mind, each sample gets you a sample statistic. So each sample would have a different statistic, but the totality of all these samples generates a margin of error to then create the confidence interval. Okay, let's look at a question. 98% confidence interval for mean pulse rate is 65 to 71 beats per minute. The interpretation, I am 98% sure that all students will have pulse rates between 65 and 71. Is true or false? That is false. Let's go back. Why is this false? This 98% is not pertaining to the number of students, it's pertaining to the number of samples. All right, 98% confidence interval for mean pulse rate, 65 to 71. The interpretation, I am 98% sure that the mean pulse rate for the sample of students will fall between 65 and 71 is also false. So if we're looking at, if you're creating a confidence interval from a sample, then actually it's not 98% sure, it's 100% sure. This interval is created from a sample such as this. So the exact center of this interval will be the population, or the sample mean generated from the sample of students. All right, same confidence interval. What about the interpretation? I am 98% sure that the mean pulse rate for the population of all students will fall between 65 and 71. And that is correct. We're 98% sure or confident that the mean pulse rate for all people, the population parameter, all students, will fall between these, fall in this interval. All right, a 98% confidence interval for mean pulse rate, 65 to 71. Okay, what about the interpretation? 98% of the pulse rates for students at this college will fall between 65 and 71. That is false. That is incorrect. Again, that 98% pertains to the number of samples, not the number of students. So if we could take many, many samples of students to compute all different sample means, they would all then generate different confidence intervals. Then 98% of those confidence intervals will contain the true population parameter. Okay, in summary, to create a 98% confidence interval for a parameter, we need to take many random samples from the population and compute the sample statistic for each sample. Then compute the standard error, which is the standard deviation for all of these statistics. This is the standard error is the standard deviation of the sampling distribution. Then we're going to use the statistic from one sample and subtract 2 times the standard error. 2 times the standard error is the margin of error for the 95% confidence interval. This is all well and good, but there is a problem. Many, many times, we only have one sample. So if we can't create many, many, many samples to create that standard error, what are we going to do? We'll have to come back and talk about that in section 3.3.